Hi everyone, today I'm going to show you how to make this flower pattern using the polar coordinates and the Cartesian coordinates, and using the trigonometry we are going to combine both of them. So what are polar coordinates? Polar coordinates are basically the points which are present in a spiral pattern in the coordinate system, and to plot them we have to plot from the origin to that point the distance, which is called the radial coordinate or r, and the angle which is making with the origin, which is called the polar axis. So now to convert it into Cartesian coordinate, we have to first draw a line downwards from that point, which is in the downwards is y, making a y-axis, and in the horizontal direction it will make a x-axis or x. So when you plot these lines, you will get a right angle triangle. So now we can use the trigonometric functions of sine and cos. Here in the cos we use the adjacent over hypotenuse, which will give us x over r, and in the sine we have opposite over hypotenuse, which will give us the y over r. Now using these we can calculate the x and the y axis for our ellipse. So let's go back and see that how we can make these in our program. So as you remember that the first thing we said is the polar coordinates using the radial coordinate and the polar axis. So we are going to make two variables. One is for the radial coordinate, and we will say the radial coordinate is 20, and let's say the angle or the polar axis is 0. At first let's put some space to it. Now after doing that, now we are going to use our trigonometric functions of the sine and the cos to calculate the x and the r. So we will say that let x is equals to r multiplied by cos angle, and we will say that let y is equals to r multiplied by sine angle. After doing that, these two, we are going to use these x and y in our ellipse. We are going to put the x comma y comma and make the circle to be of 10 diameter. Okay, once we do that, let's give a fill to it also. So we are going to fill also these circles. At first let's say it's a red color circle we want to make, and say the stroke is also have some color in it. So let's say the stroke is at first of brown color, or let's use these variables. So let's say is r comma c r comma x comma y, and let's see what will happen now. So we have a circle and it's up there in the, and it's not moving, as you can see. Why? Because what we did that we have initiated the angle, but we have not incremented it. So we need to increment this. So we have to say 0.9 angle, and now you can see the circle is appearing, but in the top left hand corner, because the angle at first is 0. When it's multiplied with x and y, it gives a 0. That makes it appear first in the top left hand corner, which is the origin 0 0. So we have to translate it. So let's translate the whole thing to the middle. Since the canvas is 400 by 400, so the half of it will be 200. Now when we use the same thing, now the circle is appearing in the middle, but we cannot see multiple of them forming any particular shape. So why is this happening? Because the background is clearing it up. So we need to move the background from the draw to the setup. And now when we run the program again, now you can see the circles are forming, but they are not moving away from the axis or have any space in them. That's why they are appearing one over each other. So what we need to do is to make a space variable. So let s is equals to, let's say the s is have a spacing of 10, and what we are going to do, we are going to add this to our formula. So r plus, we are going to say r plus s, and we are going to say r plus s in the other one also, and we are going to increment that space to give a flower pattern. So this is equals to 0.08, and let's say now we know the red color is coming, so let's put the r and the s in this one, and let's see what kind of a color we get afterwards. Okay, let's do this and let's see. Now you can see that our flower pattern starts emerging the way we are looking at, and you can see that if we let's change the x and y to s and s, and now let it work. Now you can see, might be able to see some more difference in that. The colors are changing, the colors are appearing in a more nicer way. Okay, the spacing is seems to be too much, so let's decrease the size of it. Let's say this is 8 and this is 9, and now see, now there's the pattern we are looking for. So by changing these increment of angle and the spacing, we can get different patterns, as you can see, and we can get different colors if you put the variables inside these, and we can make beautiful sunflower like pattern. The middle of the sunflower like pattern we can make. We can change the 255 also to A, and let's see what color pattern we will get now. So it starts again with the red, and let's see what color it will change more slowly. Pretty much it remains the same. So let's change it to change another R to A, and now see, now the color appearing is yellow, and it's more like a sunflower now. That's much better. If we change it to R, so basically we are now playing around with the colors, and pretty much different patterns we can make out of it. So if I do 0.9, 0.8, now which color we which kind of a pattern we get? Whoa, we can get this kind of a pattern. And if I do a little bit less than this and say 2, what pattern I will get? So now I will get this kind of a pattern pairing. So different colors, different kind of patterns you can make out of these shapes and these things. If I do both of them with and this spacing, let's see, now another pattern starts to emerge. So this is what we can do with our colors and the things which we have made here. So if we change back again to 0.9 and 0.08, we will get back to our flowery pattern. Or was it 0.8 and 0.9? Yeah, I think so. Yeah, that's better. So we will get our flower pattern like that. I want to change it from A to and this to A. Let's see what color we will get now. Now we have higher color of blue in our flower. If we do A here, A there, now we get a purple color flower. That's great. So this is what we need to do. In a very small code, we can use the polar coordinates, convert them into Cartesian using the trigonometry function, and there you have your polar flower. Thanks for watching. Bye.